everybody, getting ready to do 11.6 of Geometry Math today, Properties of Chords. Email me here if you have any questions or if you need course materials for this geometry class. Properties of Chords, 11.6, Part 1. And staple any extra classwork to this sheet. You got 46 points here of classwork to do today. And you got 2 points here to put in your notebook. Teachers, in your bell work today for your students, multiplied radicals and then simplify, then solve the right triangle, round decimals, and so solve this right triangle here. So it basically come up with your side lengths here. We got, well, I'm not going to tell you how to do it. So I'll give you 5 minutes here, students, to do this. Okay, to solve for number 1 up here, to solve this situation, simplify this, you have 8 times radical 2 squared. So to do that, basically you're doing this here. You're multiplying 8 radical 2 times 8 radical 2, which by multiplying by grouping here, 8 times 8 times, radical 2 times 2. So you get 64 square root of 4, which equals 2 times 64 is 128 for number 1. Then for number 2, you get this situation here. So we know the measure of J here is 90. Measure of angle J here, that's K though. Oh, I see. Measure of angle J equals 90 minus 35. So 90 minus 35, this will give you J here, which is 55. And then sine 35, we're going to start with this angle here, sine 35, which is our opposite over our hypotenuse. So to solve this here, JK will equal 11 times sine 35, which is 6.3, equals JK here. So 6.3 would equal JK. Now we'll take the cosine 35 of KL. Cosine 35 is adjacent over your hypotenuse, which is KL over 11. And then we solve for KL here. So we have 11 times cosine 35 equals KL. So yeah, 9.I equals KL here. So this is 9 here. So students, you should have 9 for KL. And then for JK, you should have 6.3 is what you should come up with. Okay, into our lesson today. We're going to go into a geometry activity here. Properties of angles formed by chords. So we have this situation here. Draw a circle with 2 central angles measuring 70 degrees. We got a 70-degree angle here and then a 30-degree angle here. And then label them like this. So I'm going to make you draw this circle. You get out your compass or whatever, sketch it, and then come up with a 70-degree. If you want to use a protractor, that'd be cool. Use a 70-degree angle here and a 30-degree angle there. And then draw chords now from AC. So we're going to go from here over to here. And then BD, which would be from here over to here, BD. Label the intersection E. So we're going to label this intersection here E as shown. Then find the angle of the find the measure of AEB. So AEB, what is the measure of this angle here? So how do we do that? You can use a protractor for sure to do that. I would use a protractor. Okay, into our notebook. Get out your notebook, students. Compare your angle measures with those of other students. What do you notice? Repeat steps 1 and 2 for different central angles. So we could do that from different central angles within that circle. What can you say about an angle formed by intersecting chords? So that's a good question there for you to put on your in your notebook here. What can you say about an angle formed by intersecting chords. Theorem 11.10. If two chords intersect inside a circle, then the measure of each angle formed is 1/2 the sum of the measures of the arc. So we have an arc here. This is B over here. So AB, and then we have, this is DC. This is a D here, so DC. 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. It's like, whoa. So you got angle 1 here, then angle 2. These will be vertical angles here. So it'd be this arc here, actually, AD, and then, let's see, AD, and then AB. Or we have DC here. So this would be a vertical angle here. These would be adjacent. So this would be a one angle 1, and then this angle here, these two would be vertical for that. So the symbols for measure of angle 1, it would be 1/2 of the measure of CD. CD is here. This is CD, plus the measure of arc AB, plus this measure here. So the measure of angle 1 would be 1/2 of CD and AB. And so the measure of angle 2, this angle here too, would be, the measure of that angle would be 1/2 the measure of BC. So BC would be this arc here, and then the measure of AD. So this would be the measure of AD here. So angle 2 will be 1/2 of measure of arc BC and AD, according to theorem 11.10. So let's get into an example here. Find the measure of an angle, find the value of x. So we got this here, angle x, and this is a vertical angle with angle T. And we know this is 106, and then this is 174. So the measure of x degrees here would be 1/2 of PS and RQ. RQ. Use theorem 11.10. So x degrees equals 1/2 of 106 plus 174. So we know those two measures. So when we take those measures, we have 280 here. 106 and 174 is 280. 1/2 of 280 would be 140. So that would give us 140 here. For the measure of x degrees here would be 140. Now let's go into our first guide practice here. Find the measure of an angle. So we need to find the measure of x degrees here. Students, I'm going to let you do this unless I do this for you. I might do this for you. But do that right now, you know, as we're doing this, as we do measure, as we do 1, I think you can do a number 2 on your own. But find the measure of x degrees. So we got 190 and we got a 70, right? So 190 and 70 is 260. We add these two, and then we have it. You know, we divide that by 2, we get 130. We get 130 for x degrees here because of these. We know the measure of this arc, and we know the measure of that arc. Down here, I'm going to let you do that unless I pop it up here. I do pop it up. It's your lucky day. So 66 and 70 is 136. So the measure of x degrees here is 68 degrees, is what that is. And this would be 68 here too, because we know that vertical angles equal each other, right? Let's go into another example here. Example 2, find the measure of an arc. So find the value of x degrees now. Now we do have a measure of 80 degrees here for this angle here. We know this is 80. So how do we find x degrees here? So the measure 80 degrees will equal 1/2 of the measure of AB plus the measure of CD. We know it would be 1/2 of the addition of these two here. So 80 degrees equals 1/2 of x degrees plus 60 degrees. So when we do that, when we plug in our values here, we have 1/2 x plus 30 equals 80. We solve for x, so we move this over here. And then when we solve for x, we multiply both sides by 2. We get 100 equals x. So x here, this equals 100 degrees for x. Now let's go to our next guided practice. Find the measure of the arc. We have our angle measure here of 72 degrees. And then we have an arc measure here of 99. So how would we find that? So by using our 11.10, 72 degrees here equals 1/2 of the measure of AB. We don't know what that is. And then CD we do. So 72 equals 1/2 of x degrees plus 99 degrees. 72 equals 1/2 x plus 49.5 because we multiply through here. And then 1/2 of 99 is 49.5. We continue to solve for x, and then we move this over here, and this 22.5, multiply both sides by 2, and we get 45 degrees equals x. Now, did I do number 4? I did do number 4, and by the time we crank it out here, 59 equals 1/2 70 plus x. We get 35, move that over here, 1/2 x equals 24, x equals 48. So this will equal 48 degrees. When two chords intersect, this is page 10 on your classwork, in a circle, 4 segments are formed. The following theorem shows relationship among these segments. Now this is 11.11. If two chords intersect inside a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chords. Like, what in the world does that mean? So we have two chords here, A, B, and we have C, D. This is D over here. So symbols EA. So we have, this would be EA times EB equals EC. This would be EC times ED. That's what that means. So now we can break it down into two products here. They both equal each other, the length. So what in the world can we do with that? Well, example 3, find segment length. So find the value of x. We're trying to find this here. We know this, we know this, we know this. So we got 3 out of 4 here. We need to find x. So notice that ST and QP are chords. Yes, they're chords that intersect at R. Here's our intersection point there at R. So RS, where RS times RT equals RQ times RP. So we know that by using 11.11. So since we know that, we now can solve for x. 3 times 6 equals 9 times x. 3 times 6 equals 9 times x. So when we do our arithmetic, we get 18 equals 9 times x. Then we solve for x. X equals 2. So x would equal 2 in that situation. Let's try it now in a situation. Find segment lengths here. 12 and x and 12 and 6. So okay, so we got a situation here where we're trying to solve for x here. So by using 11.11, we know that 12 times 6 has got to equal 12 times x here. So 12 times 6 equals 12x. 72 equals 12x. Solve for x, divide both sides by 12, and we get 6 equals x. Down here we have 9 times x, x equals 6 times 6. So how will we find x here on our independent practice? AB times BC has to equal DB times BE. So when we do that, we have 6 times 6. 6 times 6 has to equal x times 9. We solve for x, x equals 4. So that's using 11.11. And that is your lesson for today in geometry math. Email me here for any questions or course materials. Thank you very much.